My name is Shawn Hymel, and I'm a DevRel engineer at Edge Impulse. I'm going to talk about keyword spotting and demonstrate how you can create your own keyword spotting system using Edge Impulse. Keyword spotting system is the ability for a machine to recognize one or several particular words or keywords out of many different words, or maybe no words. You would probably recognize keyword spotting in something like a smart speaker, say an Alexa device, or whenever you say, "Hey Siri." Those are particular keywords, or also known as wake words. Alexa and Hey Siri are your wake words. Those devices listen for those keywords and respond when they hear them. They ignore everything else that's going on around them, including other conversations and other spoken words. I'm going to show you how to create a keyword spotting system using both collected data that we create ourselves using an Arduino board, as well as augmenting that data with a pre-built data set. We will then train a machine learning model and demonstrate how it can be used to perform inference. Edge Impulse is the world's leading embedded machine learning platform. It helps you build a full end-to-end machine learning pipeline to accomplish a variety of ML tasks, from regression to vibration and sound classification to object detection and predictive maintenance. You can import data from any sensor and deploy your model to almost any device. You maintain control of the data and firmware the whole time. The Edge Impulse Studio is an online platform that handles everything, including collecting data from your embedded sensors, labeling that data, performing any pre-processing calculations, and training machine learning models. This end-to-end project is known as an impulse. You can then test your impulse on live data with a connected sensor. After, the studio will guide you through the process of creating firmware or a library that will run your impulse on any number of platforms. This includes your pre-processing code, a trained neural network, and any anomaly detection code you may have so that you can perform inference locally without an internet connection. To start, head to docs.edgeimpulse.com. If you have not done so already, you will need to follow the Getting Started guide for your board. In this case, we're using the Arduino Nano 33BLE Sense. So click on that, follow these instructions. Part of that will include installing the Edge Impulse command line interface tool, as well as the Arduino command line interface tool. These should work for Windows, Mac OS, as well as Linux, so your operating system should not particularly matter. Once you have those downloaded and installed on your operating system, you will need to put your Arduino board into bootloader mode. So connect it to your computer through a USB cable, and as shown in this GIF, double click on the reset button, which I'm going to do now. You should see this yellow LED slowly pulsing. As long as you have that, you're good to go. Then download the latest Edge Impulse firmware, which we will open here, and you will want to extract that zip file. Once that's done, go into that folder, and you should see a number of files, including scripts to upload the compiled firmware and the compiled firmware itself, which is this .bin file. I'm on Windows, so I'm going to double click this batch file, or .bat. If you're on Mac, you'll want .command. If you're on Linux, you'll want .sh. So run that script. With any luck, it should connect to your Arduino board and begin flashing the firmware. What this is going to allow us to do is connect our board to our project on the Edge Impulse Studio so that we can collect data from the board itself, upload it to the studio, and train our machine learning model. When we're done, we can easily use that board again to test our model. Now that it's done, press any key to close that out, and let's head back to our browser. You'll want to head to edgeimpulse.com. If you have not done so already, create an account here and click Get Started. It will likely bring you to a demo project, but if you'd like to create your own, click on your account icon in the upper right and click on Create New Project. I'm going to call this My Space KWS for Keyword Spotting System. Let's create this project, and you can click on Audio. These will take you to the various parts and documentation to create a keyword spotting system. We are going to connect a development board, so let's get started. Go to Devices, and you'll see that you have no devices here. We want to connect a new device, so one way to do that is to click here, and you can connect any number of these devices. We're going to be using a fully supported dev board. This button will take you back to the documentation, and what that documentation will tell you that we need to do is bring up a command line. This could be the command prompt in Windows, a terminal in Linux, or Mac OS. From here, you'll want to run edge impulse daemon. If this is the first time you're doing this, this is all you'll need to run to connect your board to that project. However, if you've run it before, it will remember those settings, which is useful for setting up an entire machine learning pipeline. But if you'd like to connect your board to a different project, you'll want to use the -- clean argument. It will clean out your credentials, which means I have to enter them again, which my account is Shawn-demo. I will enter my password. Let me try that again because I messed up my password. And it should ask you which project you want to connect the device to. In this case, I'm going to connect it to my-KWS. Click Enter. And with any luck, it should pop up and say that it is connected to the project and asking me to name the device. So I'm going to click Enter. And it should tell me to go back to the studio, which I will do now. And sure enough, my Arduino board is connected. It's ready to receive data, as you can see by this green light over here. There are a number of ways we can do keyword spotting systems. One way is to use existing data and to pick one of the words available there. I'm going to show you both methods. We're going to use our board to record the words yes and no as our keywords, so we will need multiple instances of those words so that the model can train appropriately. And we will bring in a data set that's been curated for us to include a bunch of other words that are not yes or no. This will just save us some time so that we don't have to collect a bunch of keywords that are both our intended keywords as well as the words that are not our intended keyword. And some background noise helps too. From here, go to Data Acquisition. We want to have our device that's connected here, and we want to give it a label. So I'm going to show you how to do this with yes, and we want to use the built-in microphone. We're going to record for 10 seconds, and during those 10 seconds, you will want to say yes, this label, over and over again, but leave about a second between each utterance so that we can slice it up and create a bunch of different samples. Click Start Sampling. That will connect to the CLI, to our board, and tell us to start. Yes. 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 Now that I've collected those samples in the microphone, and notice that I did it with different inflections. We don't want it picking up on one inflection, and in fact you should use different voices to make this a more robust model. If you scroll down, you can see the collection here over 10 seconds. You can play it.
Yes. Yes.
And we can also go click this three dots menu and say split sample. This will bring up an editor for us. It should automatically find all the parts where we uttered that word or some word utterance. It doesn't necessarily mean it's always yes, but you'll want to check to make sure. These all look good, so I'm just going to click split. And this creates a bunch of 1-second samples that are yes for us.
Yes.
We could continue doing this for yes for no, and for our other keywords as well as some background noise. Rather than taking up a whole bunch of time, I'm actually going to head to the documentation page on Edge Impulse. If you scroll down, you should see something called pre-built data sets, and I'm going to grab the keyword spotting one. And here is the keywords data set. Let's open this. Whenever it's done, we are going to unzip it. As that's unzipping, I want to talk to you a little bit about model bias. I have a story in that I created a keyword spotting system to respond to the phrase trick or treat. I put it in a little pumpkin outside where children would come by and they would say the phrase and it would light up and play some spooky music. However, I only trained it on my voice and a female voice, thinking that should be good enough. What I failed to recognize is that the model was then trained to understand that phrase for one male, one female, adult voices. It failed completely at identifying children's voices. The only way I could get it to activate was by telling the kids to say trick or treat in their big grown-up adult voices, and that seemed to work. So that was a hard lesson for me when it came to creating a robust keyword spotting system. What that means is you will want to find a lot of different voices for both your target keywords as well as your other words that are not your target keywords. This includes sampling from different people of different genders, different cultures, ages, different types of inflections like I showed you, and distances from the microphone. You can't always assume that somebody's going to be 6 inches from a microphone. It might be the case if it's a professional recording, but that may not be the case. So take all of those things in mind when you're creating your data set for a keyword spotting system. The other thing you can do is something known as data augmentation. This data set already has that for us, where we take snippets of background noise. It could be a computer fan running, a faucet running, it could be traffic or a train going by or planes overhead, and you mix that in with various keywords and non-keyword samples to make it more like a real background. You can't always assume you're going to be in a recording studio where everything is silent, and in fact your keyword spotting system might fail if you recorded all of your keywords in silence and then you tried to deploy it in a noisy environment. So keep those things in mind when creating your data set. Now that we have the keywords, feel free to go in here and look at how they're split up. So here are all 1-second examples of no. Here's a bunch of other people saying the word yes. Unknown are other words that we did not record. It's neither yes nor no, but it's other English words. And some background noise. And that's going to be a noise category for us. To upload this, you'll want to click on the icon that says Upload Existing Data. Click Choose File. Go into the keywords. We're going to start with no. I'm going to select all of these. Click Open. Let it automatically split between training and testing. And in this case, you could enter no here, but the way those files are labeled, where the label name is the first part of the file name followed by a period, it's going to look for that and infer that label. So we'll just leave it as is and click Begin Upload. Once that's done, feel free to take a look at any files that failed to upload. So if we scroll here, looks like there was it tried to upload it a couple of times. So it uploaded fine here and then failed. So you can try uploading it again if you'd like, but only 7 failed, and that's okay for now. Sometimes it's a server error, sometimes it's a file already exists on the server, but 7 should work for our purposes. Let's do the same thing for noise. This is all the background noise. Select all of them and click Begin Upload, and let's wait for those to finish uploading. Everything worked this time, so let's go back to our files, go into unknown, and let's upload the unknown. Finally, We have one more to do, and that is yes. These are all recordings of different people saying yes that are not me, and we're going to add them to my recordings of yes. So let's say begin upload and let that continue, and we'll come back when it's done. I recommend going back into data acquisition when your upload process is finished and take a look at the different labels. You should see noise, unknown, yes, and no. In my experience, you'll need about 5 minutes of each word or each label to get something working. Don't expect it to be very robust. So here we've got about 20 minutes of each, and you'll want about 80% of your data in training and about 20% in testing. And we can filter this data. So for example, let's look at one of the unknown samples because we know what no sounds like. So you can click on it and we can play it.
7.
So this is somebody saying 7. This should be a good amount of data for us to create our keyword spotting system. Ideally, you want thousands of samples to get that robust model, or tens of thousands, but this should be a good start. Next, we want to create our impulse. In Edge Impulse, an impulse is a combination of any pre-processing code. In this case, it's slicing out windows, but we just want that 1 second example, going to any DSP, and that includes any filtering, feature extraction, creating things like the MEL frequency septral coefficients, which is actually what we're going to use. So click on that block. And MFCC stands for MEL frequency septral coefficients. This is a mathematical tool used to turn audio data into a series of spikes based on frequencies that approximate how humans hear, or living creatures hear with ears kind of like humans. This is great for understanding human voice. We also have the MEL filter bank energy, or MFE. Similar, it breaks sounds apart into a series of frequency domain spikes or a spectrum. And this is good for non-voice audio. So things like background noise or traffic or fireworks or what have you. You'd want to use MFE for your feature extraction in the processing block. However, you can play with both. I recommend trying either and seeing which works better for your particular application. But for keyword spotting, I find that MFCCs work great. So let's add that. It inputs from audio, so it takes the audio data, it will compute the MFCCs, and it's going to send that to a learning block. You can definitely give transfer learning a shot, and I recommend it. This will take a known good model with pre-trained weights and update those weights for your particular keyword. This is a great way to create a robust model. However, I'm going to show you how to do it from a regular Keras model that has not been trained, so you can see how easy this process is. This will take data from the MFCCs and feed it to the neural network. Click Save Impulse and head to the MFCC feature generation block. Here you can select different samples and see what the output of this block will be. This is what your MEL frequency septral coefficients look like when we view it as an image. And you can change some of these hyperparameters if you'd like to adjust this block, but these have been selected to work well for keyword spotting. So let's just save parameters and then click Generate Features. This will take each audio sample that we've collected and turn it into a set of MEL frequency septral coefficients. It looks like that image or a map. This describes the shape of the energy, the audio energy in various frequency bands. Time is in the x-axis and the coefficients are in that y-axis. It kind of looks like an image, and we can use image classification techniques to identify sounds. In this case, we're going to be using a convolutional neural network to do that, which are known for being able to classify images. And that's part of the reason this works very well. We're actually using image classification techniques here. Once feature generation is complete, you should see this Feature Explorer pop up. And feel free to move this around. This is actually kind of slick. It attempts to compress all those features into 3 axes so we can get a visualization of how things are clustered. Ideally, you will want your different labels to be grouped in areas that are easily separated from the other clusters of labels. That means that these different clusters can be identified from each other more easily. If they're all intermingled, your machine learning model is going to have a very hard time identifying individual classes or labels. So this is a good start for us because the different colors are grouped together rather than mingled all together as one blob. Let's head to NN classifier for our neural network. You can play with some of these hyperparameters, but I find this 1D convolutional neural network that is given to us by default works very well for keyword spotting. So click Start Training, and you can watch the training process happen over here. We're going to be training with 100 cycles or epochs, and an epoch is any time the training process uses all of the training data and runs a forward pass through the model and then computes an updated set of weights that are used to adjust how the parameter or how the model operates. We want to leave these other hyperparameters alone, but once again, on your own model, feel free to play with them to see if you can get something more accurate. If we come over and watch the training output, in theory, you should hopefully see the accuracy going up, and that is the accuracy of the training set. A validation set is pulled off from the training set and used to validate the accuracy of the model, and that validation set isn't used during training. Hopefully, the validation accuracy should also be going up. The inverse of that is the loss, which is how different an individual sample's output is from its ground truth output. So if a keyword is yes, but the model predicts unknown or noise, that has some cost function to say that the model is wrong, and that loss cost function is used to update the model's parameters during this training process. Let's give it some time to get through all of the epochs, and we will come back when the model is trained. When it's done, take a look at the confusion matrix. You can see that we're close to a 90% accuracy here, and that unknown actual label is sometimes confused with noise or a prediction of no. I think this 90% is a pretty good start for our keyword spotting system. You can likely get it to be a little more accurate if you feed it better data, more data, and tweak some of these hyperparameters. I also recommend trying out that transfer learning to see if that works better for your particular need. When you're ready to test, head to Model Testing. You can classify all of the test data that we have available. These were the 20% of samples that we set aside during the data collection process so that we could test on them using our model that has never seen these before. When it's done, you should get a similar confusion matrix, and you can see the accuracy is a little lower, and that's generally expected as our model is slightly overfit to our training data, and unknown gets confused a little more often with some of the other labels, and there's a certain uncertainty factor that happens where the model's output is below a threshold, and it's not quite meeting that threshold for these. However, 80%, once again, is still a good start for this. Let's run a live classification. You can classify on your existing test samples that we just saw, but we can also pull from our device, which should still be connected. And I'm going to run it for 10 seconds. Let's click Start Sampling. It will connect to the CLI tool that connects to the board, and this will allow me to say things. I'm talking into the microphone on my board. I'm saying things, yes, no, and hello. Once that's complete, it should classify that for you, and you can move the window around to get the classification at any given point. Here you can see the various timestamps and the prediction values, where up front it thinks it was unknown. It struggled to identify unknown versus noise in this window. And we can scroll down to where we were saying maybe yes and no over here. Sure enough, it identified yes in this part. So if we play this,
Yes. Yes.
it identified that correctly. So there's one keyword. And what about no? 97% it thinks it's no.
No.
That's the beginning of it. Let's move the window over a little bit.
No.
And sure enough, right here. So we can play that.
No.
Verify that keyword works. And unknown is something else.
And hello.
Sure enough, it identified yes and no. I hope this helps you see how you can build a keyword spotting system very simply using Edge Impulse. In a future video, we'll show you how to deploy this model to an Arduino or another platform so you can run the keyword spotting system or any model that you've created locally without needing an internet connection.